Hello, pre-calculus. First thing I want to tell you is this is super important that you try to get this conceptual understanding of what a limit is and go 8 through 6 or 8-10, and I'll give you another packet of trigonometry at the end. But calculus moves so quickly that if we can have this good conceptual understanding now, when we start calculus, we can get it done really quickly and spend more time on derivatives and integrals. So it's going to be imperative that you really know what's going on. So if you're taking calculus with me next year, you really need to make sure you go through this thoroughly and make sure you ask me some questions. It's okay. So the idea is going to be what a limit is. I gave you a definition right here. It says if f of x gets closer and closer to a number L as x gets closer and closer to C from both sides, then the limit is L is the limit of f of x as x approaches C. The behavior is written by this following writing. So it's the limit as x approaches C of f of x equals L. So I'm going to teach you how to find a limit. So that's going to be my main goal is I'm going to give you a limit and you're going to tell me what the answer is. There's going to be a lot of different ways to do this. The first way I'm going to teach you in a little bit is called by table, and it is always going to work. The problem is it takes the longest. So I want to give you a good conceptual understanding. So before we get into that, I want to give you just a quick breakdown of some stuff. So a limit is the y value. So make sure you understand that when we're finding a limit, we're finding the y value. So the notation will look just like that. The limit as x approaches 2 of a function x squared plus 1. Now, a limit is not always going to have an answer. There's going to be 3 reasons why a limit does not exist. You're going to approach 2 different numbers from the left and the right. So this is the picture. If I'm approaching x right here, if I'm approaching one number from the left and a different one from the right, if there's a jump discontinuity there, we say the limit does not exist. The second reason a limit may not exist is if you have some type of vertical asymptote. So if I'm wanting to find the limit as x approaches this vertical asymptote, if it's a vertical asymptote, we can say the limit does not exist. Now, some books and some teachers will say if both of these tails are going upwards, you could say infinity. If both are going downwards, it's negative infinity. But the answer does not exist will always work. The other is what's called oscillating behavior. We won't see this very often, but if we want to find the limit as x approaches 0 of sine of 1 over x, the graph is going to jump from positives to negatives in here, and you'll see it by real quick squiggly lines together that you can't see what's going on. If you happen to see that, which I'll give you an example in the homework, it's oscillating behavior, but that's like the least. The most important is if you have a vertical asymptote, if you're approaching the same number from the left and right. Okay, so the packet that you needed to print off will look like this. Here's the idea. You can read through this top stuff yourself, but this is just going to say if I want to find the limit as x approaches this number, if it's going to be a smooth continuous curve, the limit's going to be whatever the y value is right here of this function. Now, the graph doesn't have to exist for the limit to exist. For example, if you have a graph that looks like this is what's called a cusp. If it comes down like this, it's kind of like a little bird flying. If this doesn't exist here, but the graph still looks like this, if you're approaching the same y value from the left and right, the limit exists and it's this y value. Even though the graph doesn't exist here, a limit can exist. So you need to really understand that. The limit is what the graph is approaching from the left and right as you get closer and closer to x. And then this is the most common one that a limit does not exist. If you approach one number from the left and one number from the right, then this is going to say, hey, the limit does not exist. Okay, so let's get to the idea of limits. One way to find a limit is what is called the table method. All right, so I put it right up on top. Finding limits by the table of points method. I give you this contextual problem that just says, hey, this is C $100,000 and X is the percent of the plant capacity being used. So if you have a plant, everything's not going to be running it all the time. Sometimes there's going to be breakdowns. Sometimes there's going to be some places that happen to be off because they don't have enough workers or whatever. So they come up with this formula. So the thing is the company wants to know, they want to plan the rotation of maintenance to attempt to ensure that 80% of the capacity is always in use. What should the manager expect when the plant is operating at this ideal capacity. So what cost should the manager expect? So we want to know the cost when it's 80, okay, when we're at 80%. Well, the thing is if you plug 80 in, you get 0 over 0. I'll go over what that means later when I teach you how to do it algebraically. But here's the idea with a table. If you ever want to find the limit of a function, you take whatever the x value you're approaching is, and you go 1,000th, 100th, and 1/10 away in each direction. So you take 80 minus 1,000th, minus 100th, minus 1/10, and then same thing going to the right. And then what you do is you plug these numbers in the calculator. The idea of a limit is going to be what's happening around 80, not what's happening at 80. At 80, the graph doesn't exist. But when I plug 9.99 in, I'm like right here. And then I'm like right here. And then I'm like right here. So if you plug these numbers in, you're going to get 6.99. You're going to get 6.999. And then when you plug this in, you get 6.999. Over here, if you plug 80.01 in, you're going to be about right here, which is going to be 7.0001. This is 7.0001. Actually, let me add one more zero there. And this is 0.7001. So as you can see, from the left and the right, what number do I get closer and closer to? So in the table, if I get from 6.99, blah, 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 what number am I getting closer and closer to? 7. What number am I getting closer and closer to this way? 7. If you're approaching the same number from the left and right, that is going to be your limit. So as I approach 80, and that's negative means from the left, I'm getting closer and closer to 7. As I approach it from the right, I'm getting closer and closer to 7. So that means my limit is getting closer and closer to 7. If these two would have been separate numbers, I would have said, hey, the limit doesn't exist. Anyway, you can fill out the rest, but this just says C of x gets closer and closer to 7, and because it's in hundreds of thousands of dollars, then we would say that the cost is getting closer and closer to 700,000. Okay, so I'm going to have you do a problem like this. So here's the idea, is going to be find the limit of x approaches 1 of root x minus 1 over x minus 1. So I'm going to ask you to find the limit by table. So what you're going to do is you're going to go to 1 and you're going to go 1,000th, which I went a little more, so I apologize, but it's supposed to be 1,000th, 100th, and 1/10. 1,000th, 100th, and 1/10. That's what it should be. And then what you do is you plug these back in here. Just make sure that you put parentheses around here. You're going to see that this one would be 5.1, 5.01, 0.5001. Okay, so what am I getting closer to as I go from left and I'm getting closer and closer to 1? I'm getting closer and closer to 0.5. Then if you look over here, you're going to get something like 0.499, 0.4999, 0.4999. And if you can see, you're getting closer and closer to 0.5. If you're approaching the same number here, then that is your limit. My limit is 0.5. So the last way, same thing. I want to find the limit as x approaches -2 of this function, x plus 1 over x minus 2, or x plus 2. So what I do is I plug all these numbers. So I plug this in for x, making sure I put the top and bottom in parentheses when I plug it in my calculator, and you get 11. Then when I plug this in, I get 101. But when I would plug this one in, I'd get 1,001. So this thing is getting bigger and bigger. If something just keeps bigger and bigger, that means you're going to infinity. Then this one, if you plug -0.19 in, you're going to get -9. Then -0.99 or -999. But as you could see, this keeps getting smaller and smaller, which is negative infinity. So what happens is if these two things are not the same number, that means the limit does not exist. Now, if you graph this guy, you're going to see that at -2, this is what it's going to look like. That's what this graph will look like. So at -2, we have that one instance that was a vertical asymptote, and that's one of the instances that does not exist. So that's how you find limits by table. The next thing I want to talk to you about are one-sided limits and how to do it graphically. So I'm going to teach you algebraically is going to be the first method that we always use, which we'll do that in the next lesson. But to get a conceptual idea, I need you to understand how to do it by table and how to do it by graph that I'm going to show you. So one-sided limits mean that we're going to approach it just from the left or right. So you can read this, but if you put a little negative here, that means I'm going to look at it approached from the left. And if I put a little positive here, it means I'm going to approach it from the right. So a two-sided limit is going to be when you look at it from the left and the right, and those two numbers must be equal. So the limit exists only if I'm approaching the same number from left and right. Limits at infinity. So if I approach infinity, if you remember, this is just what my right tail is doing, and this is what my left tail is doing. So your homework is to read this, obviously, but then you'll have some homework out of the book that I give you. But let's talk about how to find something with doing it, finding limits graphically. So first, we're going to do a little pre-calculus. To identify all discontinuities, you slide from left to right, and discontinuities means that, hey, if you have to pick up your pencil, there's a discontinuity there. So when x is 0, I would have to pick up my pencil, and when x is 1. So the two discontinuities are 0 and 1. So what is the domain of this? Well, domain are all x's used. The tricky part is, even though I have a jump discontinuity, there is still an x value here. There's still an x value here. So in this case, there's an x value everywhere. Usually it's only vertical asymptotes where there's not, or if you have two open circles. So in this case, the domain is all reals. So now, this notation, remember, these things find the actual values of the graph. So when I say, what's f of -2, this is saying, what's the y value when x is -2? So what you do is you'd come over here to -2, you would go up, and the y value would be 2. So what's the y value when f is 0? Well, f is 0 here, but that's an open circle. Well, the closed circle's up here, so the y value when x is 0 is 3. So what's the y value when x is 1? Well, if you go here, the actual y value is -1. All right, so that's kind of like some pre-calculus. So let's look at the limits. This says find the limit as I approach 0 from the left. So this is what you're doing. Here is 0. So you look at the curve and you ask yourself, what y value am I getting closer and closer to as I get closer and closer to 0? The answer is -1. I'm getting closer and closer to this y value from the left. So what's the limit as I approach 0 from the right? Well, now I'm approaching 0 from the right. What y value am I getting closer and closer to? 3. So what's the limit as I approach 0? Well, here's where the idea of a limit is. I'm approaching different numbers from the left and right, so the limit does not exist. So let's look at 1. So this says let's find the limit as I approach 1 from the left. So I go to 1, and I'm approaching it from the left. So what y value am I approaching? 1. This says let's find the limit as x approaches 1 from the right, which is 1. And what's the limit in general? If these two are the same, then the limit is 1. Now remember, it's not where the graph is at, and so that's a very big conceptual idea that you must understand. The limit is what my curve is getting closer to. I'm getting closer and closer to 1. Yeah, my curve is actually at 0. At -1, or -1 down here, but the limit is 1, because the limit is what I'm approaching around it. Okay, and then this is what I'm talking about with smooth continuous curve. If I look at the limit as x approaches -2, well, here's -2 from the left and from the right. I'm getting closer and closer to what y value? 2. If it's a smooth continuous curve, that's going to be your answer, whatever the y value is. The limit as x approaches -infinity, that's what my left tail is doing. Well, if you look at your left tail, it's going upwards, so what you would put is infinity. The limit as x approaches infinity right here is my right tail. So my right tail is going upwards also, so you would put infinity. Okay, so let's look at another graph. Sometimes graphs will have vertical asymptotes in them like this one. So let's just look at A. So what's f of -2? Well, if you look, that's a vertical asymptote. So that means my graph doesn't exist at -2. So let's look at the limit around it. If I just said, what's the limit as x approaches -2 in general, if it's an asymptote, you can immediately say it does not exist. However, if you're ever approaching an asymptote from the left or right, I want you to put what direction it's going. So this says that, hey, I want to find the limit as I approach -2 from the left. So here's -2. Here's the left. So if I approach it from the left, what is my curve doing? It's going down, so you're going to put -infinity. So this says, what's the limit as I approach -2 from the right? So I go to -2 and I see what happens. I'm going upwards. I want to put infinity. And then over here are my two tails. Remember, if I say, what's the limit as x approaches -infinity? This is my left tail. Well, what's my left tail doing? Well, it's getting closer and closer to this horizontal asymptote, which is 1. The limit as x approaches infinity is my right tail, and I'm getting closer and closer to 1 again. Identify all vertical and horizontal asymptotes. Well, the vertical asymptote was x equals -2, and the horizontal was y equals 1. Okay, last page. All right, so these dotted lines on this graph just give you where the y values are supposed to be. So here's the big idea, and the first test question you'll have will look like this. I'll give you a graph without all these little dotted lines, okay? Those just tell you where it's at. So the actual graph looks like this. Okay, that's the actual graph. Those just kind of make sure you line up so we get the exact answers. So I could ask you just in general, what's f of -6? Remember, this is saying, what is my y value when x is -6? Well, -6 is here. The y value is 8. So let's talk about limits. This is going to say, hey, what's the limit as I approach 6 from the left? So it's -6. So here's -6. As I approach it from the left, what's my y value? Well, it's 8, 8, 8, 8, 8, 8 until I get here. So from the left, it's getting closer and closer to 8. So what's the limit as I approach -6 from the right? Well, if you look, okay, from the right, as I get closer and closer to -6, I'm getting closer and closer to -8 again. Sorry, those are all negatives down here. So what is my limit? If I'm approaching the same number from the left and right, that is the limit. Okay, so let's look at -2. What's f of -2? Well, f of -2 is actually down here at -5. But what's my limits? This limit says, hey, as I approach -2 from the left, well, here's -2. As I approach it from the left, what y value am I getting closer and closer to? 4. So this says, hey, what's the limit as I approach -2 from the right? So as I approach -2 from the right, I'm getting closer and closer to 4. So what's the limit as I approach -2? Well, if I'm approaching the same number from the left and right, that is my limit. Once again, this conceptual understanding is, it doesn't matter where the graph actually is. It's what's happening around the graph. So from the left and right, I'm getting closer and closer to the y value of 4, so that's what my limit is. So f of 0, smooth continuous curve. So f of 0 is 0. So as I approach 0 from the left, look, what y value am I getting closer and closer to? 0. From the right, I'm getting closer and closer to 0. So what's the limit as x approaches 0? 0. Now let's look at this one. What's f of 3? Well, f of 3, if you look up here, is actually at 9. That's where my solid circle is. But this is just saying, hey, what am I approaching as I'm getting closer to 3 from the left? So as I get closer to 3 from the left, what y value am I getting closer and closer to? 9. As I approach 3 from the right, so what value am I getting closer and closer to as I approach from 3 from the right? Well, if you look, it's 3. So what's the limit as I approach 3? The limit does not exist because I'm approaching two separate numbers from the left and right. Those are the big ideas of this. Let's look at the tails. The limit as x approaches -infinity is, what is my left tail doing? Well, if you look at your left tail, what is it always at? 8. The limit as I approach infinity, well, that's my right tail. And if you look, what's my right tail doing? Well, it's going down to -infinity. Identify vertical and horizontal asymptotes. Technically, this is a vertical asymptote or a horizontal asymptote because it's going straight left. There are no vertical asymptotes in this problem. The discontinuities are going to be -2 and 3. And the domain in this case, because all my holes are covered up and there's no vertical asymptotes, it would be all real numbers again. Okay, I gave you guys some problems on Google Classroom. I said, hey, these are the page numbers out of the calculus book, and it's under Sydney Worth's comments is the calculus book. So you don't even need, to get one or get the pages. Just click on that book, go to whatever page number I told you, copy down the problems, and you can start working on a few of them. I'll do A8 tomorrow. So good luck, and if you have questions, feel free to call me. Thank you.